So we're going to compare some functions this morning. So far in Algebra 1, we have done linear and quadratic. Linear was a straight line. Quadratic was a parabola or a U, and it could be up or down. But yesterday you did an activity that introduced you to a new function. You had something that started small, and then it grew very, very, very quickly. And the reason it grew quickly is you were doubling, you were multiplying. The important thing to know about this is called exponential. This is our new function, exponential function. An important thing to know is this will never touch the x-axis. It'll never touch 0. It'll get closer and closer and closer and hover, but it never touches it. And we'll talk more about that later. It goes really close to 0, but it shoots up really fast because it's multiplying. You can also have one that's called exponential growth. You can also have one called decay, where it comes down very quickly and then it hovers over 0, gets closer and closer. That's called exponential decay. This was like the March Madness, where it halved. The teams in the competition cut in half until you got down to 1. You never got to 0. Now, none of these. In Algebra 2, you're going to see like a V. You're going to see something like this. Those are not linear, quadratic, or exponential. So linear, straight line, quadratic, U, exponential, up quickly or down quickly. Let's go down and look at some equations. So this one's clearly linear because it has an x and a y. Linear can have an x or a y or both. This one's neither. In Algebra 1, we do not square both the x and the y. This one's neither. We've never seen an x in a denominator. So this one's tricky because you have to actually distribute to see what it is. It's 12x squared plus 15x. That is quadratic because it has the x squared. Now we get to our two new functions with an x in the exponent. X as the exponent is exponential. When this number raised to the exponent is bigger than 1, that's when it's getting bigger. It's doubling. That's your exponential growth. When you have an x in the exponent, but this number is a decimal, it's less than 1. We don't worry about the negative. We just basically look at the ones between 0 and 1. A decimal or a fraction, that means it's getting smaller. It's multiplying by 0.5, which is like cutting it in half every time. So this one would be exponential decay. It's getting smaller. So this is how you tell functions from the graph and the equation. Now let's look at the table. We did tables and we knew that if it adds or subtracts by the exact same amount every time, that's linear. So this one adds 20 every time. It's linear. Then we looked at this one's adding, add 3, add 9, add 15, add 21. That's not the same though, so it's not linear. But if we looked at the second difference, look at the difference between these. I'm adding 6, adding 6, adding 6. When the second difference is the same, that is quadratic. So let's look at some of the rest of these. Let's look at this one. Actually, this is the last one I'm going to look at. This one is not adding or subtracting, it's multiplying. This multiply by 3. So every time you're multiplying by 3, if you're not good at your facts, your multiplication, and you can't recognize that, use your calculator. Do this one divided by this one. If you get 3 every time, then you're multiplying by 3. Do you see how I'm getting bigger? When you are multiplying or dividing, that is exponential. And the fact that it's getting bigger tells you that it's exponential growth. If I had been dividing each time or multiplying by a fraction, that would be exponential decay. So linear, add the same thing every time. Quadratic, second difference is the same every time. And exponential, you're multiplying or dividing. That's how you tell the difference in the three functions that we do in Algebra 1.